Today we'll be seeing about the topic called best practices in architecting cloud applications in AWS cloud. Um, this yeah. First of all, we'll be seeing what are the why we need to deal with this particular topic and some preliminaries that we need to understand before going to the topic. Okay. First of all, in this we'll be discussing like cloud architects who are going to move their applications to cloud. Okay. How what should be the focus of them, like what things to be considered while moving their applications. Their standalone applications are where they deploy on their own servers to move to cloud environment. This is the approach, like what are the things to be considered by cloud architects while moving their enterprise class applications from a fixed environments to virtualized cloud environment from their own environment, server environment. If they wanted to move their applications to cloud environment, then what are the things to be considered? This is what the what you call overall intention to discuss the things. Okay. Before going to see what are the things to be considered, cloud architect should able to have idea about what are the benefits he will be getting by moving the what he or she application his or her applications to cloud environment. Okay. What are the benefits? Benefits are of we can say two types, like business benefits. Another one is the technical benefits. In business point of view, what are the benefits that he will be getting, while changing from enterprise application to application from fixed environment to cloud environment, where the resources are virtualized. Yeah. So now the benefits we have already seen several times. Just I will list down what are the business benefits, like segregating all the benefits which we have discussed earlier into two categories. One is business benefits, another one is technical benefits. Business benefits, almost zero upfront infrastructure investment. We don't need to invest anything in terms of infrastructure. To have infrastructure to be utilized, we don't need to invest anything in terms of establishing infrastructure. That is first benefit in terms of business. Second one is just-in-time infrastructure. Whenever we want, immediately we could able to what you call get infrastructure. That is just-in-time. See here, if your application became popular and your infrastructure did not scale, then you became a victim of your own success, isn't it? Suppose you have developed a website. Okay, that website has become popular and you could not able to scale it. Then whatever the popularity you have got, that will be wasted in vertical. In contrast to that, what we can say is, by deploying applications in the cloud, then what is the advantage that we can get? Just-in-time self-provisioning. Like immediately we could able to extend, we could able to scale the infrastructure, so that whatever the needs we have, that we can able to serve. That is one point. Sorry. In another way, like suppose you have established, you wanted to establish your own what you call physical servers. Okay, physical environment with several servers. Your estimation is like you have to maintain 5 servers in order to accomplish or in order to serve whatever the needs of your application. But you couldn't able to what you call get whatever the response you expected from audience. Then maintaining those 5 servers and establishing, you have incurred so much infrastructure cost. So that will be wasted. And if your website or your application becomes so popular, means those 5 servers may not be sufficient. You cannot buy immediately, or you cannot scale up immediately. These are the challenges. So when you move your application from your physical environment to cloud virtualized environment, then we will be getting the advantage like just in time infrastructure we could able to avail. That is the advantage. Next, more efficient resource utilization. Of course, it is the reduced advantage from the previous one. That is, whatever the resources available at the cloud, those resources can be utilized by several cloud users, so that those resources can be utilized more efficiently. That is another advantage. Next, usage based costing. How much we will be using, that much only we could able to pay. Next, suppose if you wanted to shut what you call pause your application for a certain period of time, then you can pay whatever the time you have utilized that service, you have utilized that infrastructure. That is what we can consider as the advantage called usage based costing. Next, coming to reduce time to market. It's like suppose there is a compute intensive or a data intensive job you have, which will require 500 hours to execute. With the cloud infrastructure, as we are having what you call more infrastructure, the same job can be done, okay, by launching 500 instances, and within 1 hour we could able to complete it. That is the advantage, that reduce the time to market. That is another business advantage that we can get out of this cloud environment. So these are the business benefits. And second type of benefits we can consider as technical benefits. Those technical benefits are like automation. That is a scriptable infrastructure. Like we can create an API where we could able to what you call make environment which is required to execute or execute several instances of the application over several components. Like we have built a server, okay, depending upon the need we may need to have similar server. Then we can create an API which will do that whatever the required softwares which we need, that entire software bunch, all those things we will be having, we could able to replicate by using this API. So that by using script itself we could able to establish the infrastructure. Of course, not physically. Try to understand, we are having physical server, but the same kind of environment we need to have, means that again installing installing whatever the required server software and application software and other utility softwares which we require. These all things can be done automatically by using using some script which we will be writing based by using APIs. This is the first advantage that we can observe technically. Second one is auto scaling. Of course, it is it is exist in business what you call benefits as well. You can scale your applications up and down to match your unexpected demand without any human intervention. Without any human intervention, we could able to scale your applications. Like you can create more instances without any human interventions, depending upon the demand of the users of your application. That is auto scaling. Okay. Next, proactive scaling, in the sense, let us say after, let us say now it's lockdown. We are expecting lockdown to come within a week or 10 days, something like that. Then by predicting that if you buy some things which will cost more when lockdown imposes. That is proactive thinking. Similar way, whenever there will be a need, such kind of guessing is there, then proactively the infrastructure can be scaled so that the cost will be reduced. That is what proactive scaling. See here, scale your application up and down to meet your anticipated demand. Okay, we'll be expecting this much demand will be there. With the proper planning, understanding of your traffic pattern, so that you keep your costs low while scaling. Whenever we wanted to scale, that time the cost may be more. So by anticipating the demand of the scaling, we could able to plan, and we could able to reduce the cost. This is what the technical advantage that we can get. Next, more efficient development life cycle. This may be like whatever the development infrastructure that we wanted to have, like 7 servers if we wanted to have, then we can make cloning, like same kind of servers we wanted to have 7 copies. So cloning we can use, so that the development life cycle will be more efficient and improved testability. It's like never run out of hardware for testing. Like what we can say is instant test lab we can create, so that with pre-configured environments we can perform testing. That is the technical advantage of cloud computing. Next, disaster recovery and business continuity. Of course, the name itself, these terms are self-explanatory. Yeah. Next, overflow the traffic to the cloud. It's like with a few clicks and effective load balancing tactics, you can create a complete overflow proof application by routing excessive traffic to the cloud. So whatever the traffic that is beyond the allowed ones, those all we can easily redirect to the cloud, so that cloud will take care of all the things. This is about what you call technical benefits that we can get from this. Yeah. So these are the technical benefits. These are the business benefits of cloud computing. So now let us introduce this Amazon Web Server and Web Services Cloud, AWS. This is famous cloud environment where we could able to deploy our applications by paying some amount. Okay, yeah. Before going to see actual topic, like what are the best practices to deploy our applications in AWS cloud, let us introduce some terms related to AWS cloud. Yeah. Okay. So this AWS, that is Amazon Web Services Cloud, it is a highly reliable and scalable infrastructure for deploying web scale solutions, or we can say applications with minimal support and administration cost. The support cost will be less and administration cost also less, and more flexibility than you have come to expect from your own infrastructure. Like if you develop, if you wanted to have your own infrastructure, yeah, if you wanted to have your own infrastructure, still this AWS, Amazon Web Services Cloud, whatever the flexibility it will provide, this is more efficient than whatever the benefits that you will get when you establish your own infrastructure, your own server or data center flexibility on your premise. Okay, that is how these all will be provided. We will be seeing. See here, Amazon Web Services Cloud provides highly reliable and scalable infrastructure for deploying your applications with minimal costs and more flexibility than you expect from your own infrastructure, either on premises or at a data center facility. Okay, that is the now. This AWS offers variety of infrastructure services today. Here, those infrastructure services we can see in this diagram. Here you can see Amazon Simple Database Domains, Amazon SNS Topics, Amazon SQS Queues, okay, Simple Queuing Systems. Okay, next relational database services. These are the additional services like auto scaling, Elastic LB, next CloudWatch, MapReduce, job flows. All these things will be part of Amazon Web Services. Okay, first of all, we'll see one by one what are these all. Okay, then we will come back to this here. AWS terminology will be introducing here. Amazon EC2. This name is famous. Amazon EC2 stands for Amazon Elastic Computing Cloud. EC2 is a web service that provides resizable compute capacity in the cloud. Yeah, here you see this is our application. This will be available to utilize any of these services depending upon the need. Okay, this is actually physical infrastructure that we have. See here, this is our application. Here we are having AWS services, and these are the actual physical infrastructure which are available. This kind of what you call a hierarchy we have seen previously when we discuss about the virtualization layer. Okay, we can say this entire thing as the cloud virtualized cloud environment. Okay, where it will be having several physical infrastructure underlying with the underlying hardware. So these underlying hardware devices or resources can be categorized into several regions. Next, each region will be having several zones, and each zone will be having several locations. This is the hierarchy actually. Here you try to understand whatever the resources we have or the infrastructure we have, those can be divided or those can spread over several geographical regions, and each region can contain several zones. Next, each zone will contain several locations. We'll see in detail about these, like formally the definitions and all we will be seeing. Okay, so now in order to utilize these resources, this physical infrastructure, we are having several services which are offered by AWS. What is meant by AWS? Amazon Web Services. In those, we are having relational database services. We are having enterprise what you call basic storage services, MapReduce services. These kind of several services we have in order to accomplish needs of the application on top of this physical infrastructure. Okay, now we'll be seeing one by one. See here, Amazon EC2 Elastic Compute Cloud. It provides a resizable compute capacity in the cloud. Whatever the capacity we require, time to time, we can resize the compute capacity through this service called EC2. Okay. Next, there is a term called Amazon Machine Image. Amazon Machine Image, in short, AMI. What it will contain is whatever the for the machine, what we require is some operating system we require, some application softwares we require, and how those all needs to be integrated. Some settings related to it. So you can bundle all these like operating system, application software, and associated configuration settings together, and we will call such kind of thing as Amazon Machine Image, AMI. Okay, these AMIs can be used to provision multiple virtualized instances. Virtualized instances we could able to create with this AMIs. Okay, Amazon Machine Images. Suppose if you bundle one setting like Windows we want, and some application softwares. Can you name any application softwares that you know? Yeah, anyone can able to tell example for application software? Yes. A broad classification of softwares we can say like system softwares, application softwares. Have you heard about it? Yes, system software, application software. What is meant by system software? Of course, you can come to the point application software. Can you give any example for application software? Yes.
Like Google Chrome, sir.
Google Chrome. Yeah, browser we can consider as application software. Yeah, any other? Can I consider MS Office as application software?
Yes, sir.
Yeah. So the, system software means?
Operating systems.
Yeah, operating system. Any other? Can I consider a compiler as system software? Compiler. Okay, you check it out. So basically there is there are two categories: system software, application software. So if you make an image like Amazon machine vertical, what is it? AMI machine instance, machine image AMI, then it can contain like operating system, some application softwares, and configuration settings. How those application softwares can be uh, allowed access, all these things will be part of configuration settings. Then if you create an image called AMI, then by using this image we can create multiple instances of systems like as we have discussed in while discussing article benefits, technical benefits, we can clone it like AMI we have created. Same kind of environment we have to create, like same kind of servers we wanted to maintain seven number of servers we have to maintain. Means for each server, what has to be done? Same vertical operating system, application software, all these things are the requirement. Then we will create AMI. By using this AMI, we could able to make a cloning of several servers, several instances of servers. This is the advantage of our usage of AMI. Is it clear? Yes.
Yes, sir.
Now here we are having options like we can purchase these web services. Okay, the infrastructure based upon three modes like on-demand service, reserved instances. Okay, on-demand instances, reserved instances. Another one is the spot instances. Three kinds we are having. On-demand in the sense in which you pay for the instances by the hours. We will be fixing for a certain amount of time. Okay, how many hours we will be using, that much accordingly we will pay. Okay, that is on demand. Next, reserved instances in the sense certain amount of time we will be reserving the instances. Okay, with by paying like will be taking for lease. Okay, in which you pay a low one-time payment and receive a lower usage rate to run the instances than the on-demand instance. Okay, lower usage rate will be depositing. Why? Because we are reserving for big amount of time. That is what the second one, that is the reserved instances. Next, coming to the third one, that is the spot instances, where you can bid for unused capacity and further reduce your cost. This is about the third one. One is on-demand instances. Second one is reserved instances. Third one is spot instances. These are the three types of instances that we can hire. Now, instances can be launched in one or more geographical regions. So, here you see Amazon EC2 instances. We are having three types of instances: on-demand, reserved, or spot instances. Okay, these instances can be realized with this physical infrastructure. In this physical infrastructure, we are whatever the resources we have, those can be launched in one or more geographical regions, as we have seen earlier. Next, each region has multiple availability zones, and availability zones are nothing but distinct locations that are engineered to be insulated from failures in other availability zones. Like if one particular zone availability zone is failed, then that should not affect another zone. Such kind of insulated zones we will be identifying. Those we will call it as availability zones. Okay, each region will be having several availability zones and provide inexpensive, low latency network connectivity. What is meant by latency? Latency we can consider in normal terms like delay. Okay, less delay network connectivity we should have. Like within no time we should able to communicate. That is what the requirement of availability zone to other availability. From within a zone, whatever the availability zones we have, among those the communication needs to be taken place with no time, with less delay. We should able to communicate the zones within a region. That is the requirement. Next, coming to elastic IP addresses. What is meant by elastic IP addresses? It is like one IP address will be having statically, that is mapped to one server. Let us try to understand this point. One IP address we are having. This IP address is mapped to one server. Let us say this server has failed. Then we have to deploy whatever the application we have deployed in this particular server in another server. By using this same IP, user could able to access. So this IP, whatever the static IP address we have used, that should be dynamically mapped to another server in case of server failure. If one server damaged or failed or down, then another server will be up. Okay, this server will be having another address, but whatever the static IP we have selected, that static IP should able to map to the new server dynamically. Okay, this is nothing but elastic IP addresses, elastic IP services we can say. Elastic IP in the sense one IP address, static IP will be having, that will be associated with the one server. Suppose this server is down, then another server will be up. Still with the same IP address, you should able to map to the new server. That is nothing but elastic IP. Is it clear?
Yes, sir.
Yeah. So now elastic IP addresses allow you to allocate a static IP address and programmatically assign to an instance. Programmatically we will assign to an instance. You can enable monitoring. This about this elastic IP we'll get afterwards. Okay, but the concept is the same. Now you can there is another service called Amazon CloudWatch, which enables us to monitor each and every instance of Amazon EC2. Instances can be of three types we have seen, right? Each instance can be monitored by using the service called Amazon CloudWatch in order to gain visibility into resource utilization, like what are the resources which are being availed by particular instance. This can be monitored, and operational performance can be monitored, overall demand patterns. These all things can be monitored by using the service called Amazon CloudWatch. Okay, we have seen Amazon Machine Image, Amazon CloudWatch, Elastic IP, and several instances. That is Amazon EC2. These all are basic vertical components that we have in AWS. Okay, just we are trying to introduce to those components. Whenever we require a certain service, which component of AWS or which service of AWS we have to invoke, or which will be taken care of our required service, will come to know. Okay, this is Amazon CloudWatch is to enable monitoring regarding resource utilization, operational performance, and overall demand patterns. This is about Amazon CloudWatch. Next, there is another one called Amazon Elastic Block Storage. The name itself indicating here Amazon Elastic Block Storage, EBS. Here this volumes provide, okay, EBS volumes provide network attached persistent storage. Persistent in the sense, in general we can consider as a permanent, okay, permanent storage to EC2 instances. Point in time consistent snapshots of EBS volumes can be created and stored on AWS, Amazon triple S, actually S3 we can say, Amazon S3. Here EC2 instances can be stored in EBS. Amazon EC2 instances can be stored in EBS, that is Amazon Elastic Block Storage. Next, point in time consistent snapshots, in the sense snapshots in the sense at one, but it's like you will call a snap photo as a snap, right? Snapshot or snap you will be calling, take a snap, or like that. Snap you will refer for a photo. What sort of information it will contain at one particular instance? What is the what is the vertical information that you can grab? That is nothing but snapshot, snap. Similarly, at one particular time, what is the database or what is the state of the database, that we can consider as snapshot. Okay, this will be stored in Amazon Simple Storage Service. Okay, Amazon S3 will be able to create and store these kind of snapshots of EBS. Try to understand here. There is a link between EBS, EC2, and S3. What EBS will contain is persistent storage to each EC2 instance. Okay, every instance will be stored in EBS. Okay, EBS will contain some storage. Now, whatever the it's like, it is a we can consider in database perspective. I can give you one clarity. Like you consider a table we are having in your database. Okay, that entire table or a list of tables we can consider as database. Okay, that only I'm saying as EBS. We are having certain tables. Now at one particular point, okay, at one particular point, whatever the data that we are having within those tables, we can consider as snapshot. Okay, at one particular point, like that, there can be multiple snapshots available. Okay, for every 5 minutes or every 50 seconds, we will be getting the snapshot. Okay, then so now what we, so here for every 50 seconds or 5 minutes, we will be taking the snapshot. That means whatever the data available in all the tables, we will store in some storage. Okay, so those snapshots, whatever we are taking, that will be stored in Amazon S3. Okay, simple storage service. By using S3, we will be storing these all snapshots into a database. Okay, what is the database? EBS. Got it? So this is about the relation between EC2, EBS, and S3. Next, one more thing, Amazon Simple Database Service. Okay, Simple Database. Here, it is a web service that provides the core functionality of a database. Real-time lookup, that means we can access whatever the information we require. These by querying this structured data, this entire thing, normal database functionality we could able to achieve by using Amazon Simple DB. Okay. Next, coming to another service called Amazon Relational Database Service, provides easy way to set up, operate, and scale a relational database in the cloud. This is another one, Amazon Relational Database Service, Amazon RTS. Okay, and here we will be having by default MySQL database actually in this. Next, Amazon Simple Queue Service, Amazon SQS, is a reliable, highly scalable hosted distributed queue for storing messages. Okay, among application components or computers, we will be having certain messages. Those all messages will be stored and maintained by using the service called Amazon SQS, Simple Queue Service. Next, another one is Amazon Elastic MapReduce, which will provide like support for whatever the MapReduce jobs. We have seen MapReduce, Mapper, Reducer, this kind of thing. MapReduce framework we have seen in terms of Aneka. Do you remember it? Yes. What is meant by Mapper, Reducer? How an application can be application can be modeled in such a way that whatever the systems or instances that we have, several cores we have, how we can able to utilize properly by using this MapReduce, by using some examples we have seen. Do you remember it? MapReduce framework. Amazon will provide Elastic MapReduce service, which will enable us to use our host Hadoop framework. Actually, this Hadoop will support MapReduce programs to execute. Okay, it will take care of how many mappers to create, how many reducers to create, which are the mappers, which are the reducers. All these things will be taken care by Hadoop. But what is the responsibility of the user or the application programmer is framing the mapper logic and framing the reducer logic. That's it. How many mappers will be executed, how data will be distributed among these mappers, all these things will be taken care by the framework called Hadoop. Okay, so Amazon Elastic MapReduce will, the service will provide us to allow to host Hadoop framework, where we could able to execute MapReduce programs, MapReduce jobs. That is Amazon Elastic MapReduce. Next, there is a term called job flow. It is nothing but sequence of MapReduce steps. This is called job flow. Next, another one is SNS service, Amazon SNS service. It is a simple way to notify any notification, like notify applications or people from cloud by creating topics, like we'll get notifications in mail or in Facebook regarding there will be several topics, right? Just to consider Facebook, there will be several topics like friend request, one topic, next messages, one topic, or groups, another topic, like that. Several topics will be having, and Amazon Simple Notification Service will enable you to get notification regarding interested topics. Whatever the topics we have created, accordingly we will get notifications. That is SNS service. Next, coming to VPC, Virtual Private Cloud Service, allows you to extend your corporate network into private cloud contained within AWS. This will make us to create virtual private networks, and there is a tunnel called IPsec tunnel, which will enable you to create secure connection between gateway in your data center and gateway in AWS. There is a tunnel called IPsec tunnel to provide an interface between our data center and the AWS. Okay, these are the several services which are offered by AWS. Okay, here simply quickly we'll go through whatever the components we have seen. Like here you see Amazon Elastic MapReduce job flows. What is meant by job flow? It is a sequence of MapReduce jobs, right? Tasks we can consider. Next, this AWS will provide a service to support this kind of job flows. Next, this RDS is nothing but relational database services, where we could able to query for a certain data. We can look up and query for the data, structured data we can consider. Next, EC2 instances we have seen 3 types of instances. Next, EWS we have seen, EBS we have seen. Next, SNS we have seen, SQS we have seen, simple database services we have seen. Yeah, VPC. These are certain components that we have in AWS, which are designated for several services on top of this physical infrastructure. And we have seen what are the reasons, availability zones and locations. And within availability zones, there is a need to have certain less delay network availability. These are the AWS services. Yeah, these are the simple terms which we need to have idea to discuss what are the best practices in order to host our application in the cloud. Okay, cloud architects basically why we are discussing all these things is we have to keep certain things while deploying. Like as a cloud architect, let us consider I am the cloud architect. I wanted to deploy my applications in AWS cloud, Amazon Web Services Cloud. I wanted to deploy my application. Then what should be my approach? What are the best practices that I can do in order to host my applications in AWS cloud? This is the major topic. In order to assess what are the benefits, we have seen technical benefits, business benefits, and what are the component, what are the basic services that we have in AWS. Okay, if a cloud architect, as a cloud architect, if I know these 3 things, one is what are the technical benefits, what are the business benefits, and what are the services available in AWS, then depending upon the need, I could able to use these all, okay, these services to host my application in the AWS cloud. Okay, now we will see one of the best practices out of 5 or 6 available best practices. Okay, at least one we will see now. Yeah, so here cloud best practices. The basic one of the best practice is design for failure and nothing will fail. Here the name itself indicating we will try to prepare our cloud application in such a way that it will fail. What if we deploy in cloud, if it fails, what we do? That is the approach we will do, so that whenever really if it fails, it will not cause any problem for us. Okay, for the user, it will not cause anything. Okay, that is basic approach here. That is the first one, design for failure and nothing will fail. Here we will make use of rule of thumb. What does it mean is we will be a pessimist when designing architectures in the cloud. That means assume things will fail. Okay, assume things will fail, and what we will do is we will design, implement and deploy for automated recovery from failure. This is our approach. What is the rule of thumb is we will be assuming that things will fail. But we will design, implement, and deploy our applications where we could able to recover our applications automatically from failure. Okay, this is what the approach that we will follow. This is one of the cloud practices. So in particular, assume that here there are two kinds of failures we can consider. Hardware failure. In this particular, assume that your hardware will fail. Hardware in the sense outages will occur, like some disaster will strike your application, and that you will be slammed with more than expected number of requested per second. All these things are related to infrastructure or hardware failures. Then assume that with the time your application software will fail. Okay, by being a pessimist, you end up thinking about recovery strategies. Okay, we have to think about recovery strategies during design time itself, which helps in designing overall system better. This is the basic approach. While as a cloud architect, while designing itself, if you think that if hardware failures, then our application software failure, then how our application could able to recover from it, from the failure. If you consider and design accordingly, then that is the best practice we can consider. Understand my point? Yes.
Yes, sir.
Yeah. So this is one of the best practices. In the next class, we will see in detail about these best practices. Actual topic we will see in the next class. And now we are ready to discuss what are the best practices to deploy our cloud our application to the cloud. Okay, as a cloud architect. Okay, this is what the topic that we'll see in the next class. Okay. Thank you, ma. You can enter your roll number and can leave.